Hello everyone and welcome back to the next lecture. In this lecture we'll be talking about the Asset Lookdev environment, and we will be actually doing some Lookdev on a proper geometry. So before we jump into doing some shading networks, let's bring in a new geometry, and I will create an Import-O-Matic node, which is kind of the default to bring in geometry actually. So I'm just hitting the plus icon on top, add Alembic, and I go to my source directory and I will just load a new asset called Lego and load that in. And before we can start Lookdeving, we need to actually bring it into our stream. So in our in our asset switch, I just want to create a new port, and I want to rename this to Lego actually, like that. And now we have that created. Let's hook up the Import-O-Matic to that Lego one and maybe rename this to Import-O-Matic_Lego so I know which one it is. The next step would be to create a new asset. So in our project settings and the variables, I just go to asset and I just type in Lego as well, which now creates that. And because everything in this template is automated, the geometry is displayed, it actually it gets assigned the proper shader just because the geometry naming convention is inherited, and we have plastic, and whatever has a plastic tag and also an SDM tag will get subdivided, and it will get our generic default plastic shader. So this is all we gotta do, and next step would be to go into the Lookdev environment and create a, let's say we want to create a Lego shader. In the meantime, let's just render actually from our VS Studio from the variable switch and hit render in the meantime. And now we can create the shader, just copy this and paste. And let's just rename it to maybe very simple, just maybe Lego. Hitting enter here to enable the renamer. Just type in Lego like that, remove the one in the background and hook it up to our network. And you can see everything is being updated automatically. And within the shader, we would just need to actually go to the plastic here and see if we can change, maybe just for now, just change a yellow color for our generic Lego material. That's just something like that. And head back out all the way, and now we go into the material assign stack, and let's just duplicate the plastic shader here, duplicate that and just rename this to MA Lego like that. Oops, like if I can spell that, Lego like so. And now we want to choose our material, which lives in here, Mat Lego, drag that in here, and then we have a path. Instead of using a collection, let's just use paths instead. And right now we have already material assignments on these locations where we ever have plastic. You can see in the attributes that we have the plastic shader assigned to this location. So what we can actually do, go back to the plastic and maybe just select these locations, and we can see it's pretty generic wherever they are being assigned. So what we can do instead is use that plastic collection. Because everything is a plastic, we can just use that for our Lego assignment as well. So I just go into the collections, right click in here, add scene root collections, choose a plastic, hit OK, and now everything should be assigned to that. And another thing which might come in handy is actually to see our assignments in the scene graph. And to do that, you can go in the preferences, and underneath the scene graph you have a few options, and I have already created this material assign. You can just create that yourself like that, create material assign, enable that. I'm actually not sure what color means, but it doesn't matter. So that's all we need, and now we can actually see the locations where you can see assignments happening. And this is our location for that shader, and we can see it is assigned. So if I would render now, let's just see what we get. We should be expecting to see a yellow little Lego figure. And that's exactly what happens. So now let's actually try to eyeball this plastic shader a bit more. So to do that, I have in the catalog, I have already our reference images dragged in. So it's on slot 2. So all I can do now is hit 2, and this will load in our reference. So what I want to do, I want to jump into the Lego network, go in here where I have my standard surface shader. I just want to rename this maybe to Lego, and for now let's just use a diffuse color, and I just want to pick that. So I click the color swatch, and I want to click and hold the pipette icon and just move over so I get a kind of like a darker yellowish color, which is more or less in the same hue as our Lego figurine. Maybe I can desaturate it a bit and just go a bit lower on the diffuse. And what I want to do now is start a live render session, and for that to work I would need to make sure that our locations in the scene graph are set to live. It's not a good habit to just shift click everything, so it just takes a bit longer to iterate to find new changes in the scene graph. So it's always a good habit to try to select the exact locations to update. And for the Lego, for the geometry, you can actually just shift click because it's a few more locations, and we just don't want to do the manual work of selecting all of those. So hitting save, and now right clicking our studio one, or actually going down here and starting a live render from down there. In the meantime, let's just grade our VS nodes to something greenish, just that it's easier to read, and we get a nice update also in the scene graph location. Alright, let's see if that works. If I change my base to maybe 0.2, see if the live render does do its job. And it seems it's actually not updating, and it's a possibility that the location, because this is a child material, we just need to select all of the Lego ones, or it just takes a bit of time. So actually it did update now, it took a bit of time. Let's just select the region here and see if that's better. With shift right click and drag a region to load that up. And now if I change my base color, you can see now it's updating a lot faster. So I think this color is actually pretty good. If I just switch back to my reference, you can see this is overly bright, but it's pretty close to this color. The only thing what I would say is changing maybe the specular roughness. So let's head over to specular and reduce our roughness maybe to 0.15, so we get a lot more shiny response. And I think the IOR is a bit high, so maybe try 4.8 or 4.7 just to reduce the overall spec. We can even go a bit further down. Let's try maybe just 0.14 just to reduce the reflection amount. I think that looks pretty good. So this would be our basic shader. Right now this is a fully diffuse shader, and I think we should actually go the way to create a scattery shader. And to do that, it's fairly straightforward. We would just need to copy our base color and paste that into the subsurface scattering color, paste it like that. And now you can see we have our little Lego guy's hand, and the hand is one of the thinner areas. So let's just region select this guy and now bring the subsurface back up to 1. And now we can see it's getting very translucent. So let's switch the mode from diffusion to random walk. Now it gets very bright, and that's because the scene scale is not accurate. So let's just actually reduce the scene scale by a factor of 10, so 0.1, and let's see what we get. And I think this might work just because we have a radius of 1, which means it's scattering 1 unit. And we just want to actually reduce that as well. So I'm copying the color again, pasting that into my radius like so. And now we should get a very saturated shader. And what you want to do now is maybe go into hue, and just move it a bit into the orange, so we get a nicer response there, and desaturate it quite a bit. And then reduce the value, which is also a radius multiplier. So if it's a lower radius, the light will not enter the object so deeply. So a good habit is now to actually render that maybe from a side lit environment. So to do that, let's just bring in our reference and make our lights, and just shift click that group to visualize our background images, or our sphere actually, and then just rotate and see until we get those lights, those soft boxes, maybe more from the side, maybe something like frame 80. And let's just do another live render and see what we get now. And then next up we will be tweaking a shader, and we might actually bring in a procedural way as well, just a little bit noise to break up the speck. So this already looks very promising. We get a nice side-lit little Lego figurine, and you can see that how deep the light is penetrating the object. You can see we get this nice edge of light. If I go back to the reference, you can actually see that happening as well. You can first of all see that on the back side of the hand, you can see this nice scattery look. And you can also see it on these edges here, that you get these brighter, not the white line here, but then a bit further to the right, you can see how the color bleeds into the object. And this is kind of what we get here. We get this nice backscatter, and we see that these lines are being blended in with some light. So I think this is a pretty good plastic shader. The next step would be to break up the speck just to get a bit of interesting surface irregularities. So in the Lookdev environment, let's go into that Lego network. And right now we don't have anything specific. So let's just create a noise shader by hitting S. It's a shortcut we defined in an earlier lecture. If you don't have that set up, what you can do instead is hit Tab, do an ASN, type ASN for Arnold shading node, edit that, change your node type to whatever you want. So this time you would like a noise like we did up here. So this is now the same to get the same result. But I like the shortcut S, and we have that noise already. And the next step would be to create a bump by hitting the S key again, bump to D. And this will modulate our surface normals. Let's just region render that guy, hook up the red channel to the bump map, and the bump output goes into the network, into the shading surface shader, and we look for normal. If we cannot find it, let's just search for normal and then hook that up. So now the bump should be connected, and the default values are pretty steep. So if we do another live render, we can actually see what that map looked like, and I guess it's a lot way too strong. Let's just see until it loads up, and you can see it looks very funky. So let's head into the bump to D and change the height maybe to 0.01. And this should bring us almost back to our original look, but I think the frequency is way too low. So let's just boost it up by scaling it maybe by a factor of 60 and see what we get then. And we can see now we get some breakup, we get some texture in here, and I still think the size is not correct. It's still too big. So maybe try a scale of 80 for this. And now we should have very small frequency noise, and that's exactly what we want. Obviously way too strong. So we can now actually go lower on the bump height, but I rather keep this value to 1. And I would just like to try to multiply it somewhere in here. So we have this amplitude. If I put that to 0, let's see what we get then. We get a very clean surface. And if I put an amplitude really low in here, let's see if this actually does what it's supposed to do. And it actually does. So we can kind of do a pre-control of the map in the noise, and then we can still go back to the bump to D node and tweak that even more. But let's just divide that another time by 10. So I'm just typing divided by 10, which adds another decimal. And now we should have a very small amount of noise. And I think that is actually pretty good. We can see this slight breakup there, and this is exactly what we want. If you want to add more detail, you can add another octave, which adds a lot more high frequency noise in this. And you can see that's looked already a lot better. So let's try maybe 3. And this now looks pretty good. I think the noise is still too strong. A Lego head or Lego figure is still smoother. So let's just go now into the bump, and let's just reduce that by half as well. And now the bump is very subtly in here, and you can see now this looks very great. So let's render a full image and see what that looks like. Right, so now we have the rendered Lego figure, and you can see the shader works actually pretty well. We can see the backlighting, we can see the layers light scattering through the legs. The radius might be a bit too much. It might just scatter a tiny bit too much. So what we can do, go back to the Lego shader, and let's just try to reduce the let's just try to reduce the radius a bit more. So right now the value is on 0.24, and let's just go maybe a value of 0.2 and just be done with that. And so the next step would be to create some variation between the figures. So we can see in our reference image, we have blue arms and we have orange bodies. So let's just try to replicate that as well. So if I now head over to our work area, let's see what we can do if I edit this material. So we right now don't have a work area for the Lego figure. So let's go to the switch and create a new port and rename this to Lego, like that. And now we are working in this stream here, which is currently not connected. So let's create a new dot and hitting the period icon one more time, that, and just hook that up to the Lego. And now we have our scene graph updating properly. So what we can do now, let's say we want to change the shader on the arms. All we got to do now is create a material like that. And all we want to do now is override it. So we can go to override materials and select the objects which we want to change. So we want to go into the arm, and we can see now these are the locations where the shader lives on. And we want the left and the right arm, and we just want to say append scene graph selection. But the problem is, if we want to work with instances, more than one Lego, we would need to actually change the Lego one to a custom command. So let's do that instead by just dragging one arm item in here and now updating the location. So we just want to make sure that the Lego one is an asterisk. We want arm, and we want any arm which is tagged LOR. So let's see what we get now. If I find and display, we get these two locations, and that's exactly what we need. I have just noticed that actually our geometry comes in within Geo under Lego ABC, and that is definitely not correct. It should come in underneath Geo. So let's just remove this guy here. And now the Geo Lego 1 is the proper location. We would need to adjust our material edit, because right now it's still looking at that location. So let's just remove this path and see what we return. If I actually search and display, we get all the correct things back. So exactly what we want. And now the next step is to see if we actually have some overrides on the arm material. So if I select the arm, go to the attributes of that and do a implicit resolve on, we should be able to see the material and the parameters and the spec and the color. So right now these are the values which are exposed, but it's base color and it's specular roughness, which is good, but we would like to get the scattering. So let's head back to the Lookdev environment, go into the network, edit the surface shader, and within the subsurface scattering tabs, let's just search for color, click the little wrench on the side and do edit parameters, and just name this SSS underscore color, and this should be in the group SSS, and do the same thing for the radius. So let's just type all this out like so. And now these two values are exposed as well. We don't need the base color to be exposed, so let's just remove it from the public interface, and we can actually just disable and make it maybe 0, so we don't have any base colors. We have the specular roughness exposed, which is fine if we want to do some little overrides. And let's just say we want to be able to control the bump intensity as well. So let's just expose that too. So we put this under bump like that, and then we want to call it height, and this goes under the bump group like so. Okay, so now these values are overridden, and if I head back home and look at this, we now have the option to drop attributes here. So I'm still on the arm shader, so let's drop these attributes down here. We have them exposed now underneath attributes of that location, and all I can do now is just drag these guys in here one by one, radius and color, and let's just say I want to control the bump as well for the arms. So this is currently what we have, and let's just start the live render session now and see how that would work. So make sure everything is still the same. Let's just hit live render and see if we get the render started and if we are able to adjust the arm colors. So right now nothing changed because we didn't overwrite the color values itself. Let's just drag a region around this arm here, hit home to do a one-on-one render. And now let's just play and change our hue for the arm color to maybe a blue and see if that actually does update it. And you can see it happened easily. I forgot to make the meshes live, so I just did that and it just popped in. So now we want to work on the color itself. Let's just check the reference. It's a very light blue, but it's very thick. It doesn't feel it's so scattery. And this one still feels a bit too translucent in my opinion. So let's just go to the color and maybe just copy the SSS color and paste that in here. And then let's just try to paste the value again, copy and paste again. So now we have the same hue, but we want to change the first of all the saturation, and then obviously we want to change the radius so it's a bit more solid. And you can see if you reduce the radius, you get a more solid looking material. And I think the blue is too blue. It's too saturated, so let's remove that a bit, and the overall value as well, so it's a bit darker. Maybe that's a bit too much, and then boost the radius a bit. Let's see what we get now. So I think this might just work, and I think in the reference you can see there's a bit more roughness to the arms, so let's just boost that as well. Because we exposed the bump height, we can just overwrite that in this material edit now. So let's just do 0.8 and hit enter. And now you can see the arm is a bit more bumpy than the rest of the body. And we can even go a bit more, maybe 0.9, and we can still change the hue a bit, maybe a bit towards the cyan colors. And obviously now we know how it works. So let's just do the same thing quickly for the arms. So this is material MO, material override for the arms, and let's just copy and paste this and rename this to legs and torso, I guess. And let's just change the objects from the torso, select this, the legs, and we want the hip as well. So these three guys. So let's just create a few custom commands here. So we are in the arm path. Let's just drag in the hip. Make sure we remove the one with an asterisk, like that. And then we have that path hard-coded, which is totally fine because it will not change. We do the same for the torso. So let's just remove the top string, paste that in, replace the one with an asterisk. And then we have both of these legs. So add one more custom one, drag in the legs in here, replace the one with an asterisk, and replace the L with an asterisk as well. So let's see if we get all the selections we want. We can actually also say or choose to select them, and now everything gets selected. And just out of the blue, let's just change the colors to a orange. Let's just try to eyeball something here. We want it to be more red, maybe like that, and a bit more value, maybe something like that. And the color, let's just pick it to be this, and then we just maybe make it brighter, like desaturated, more yellowish. Let's just see what that looks like. And also before we start, let's just reduce the bump to maybe 0.3, and let's just start a live render session. And we can already see how it's working, and it feels very translucent and very soft, almost like jelly. So we definitely want it to be a lot more diffuse, and you can see this is it feels very solid, and we just get this slight color bleed in here. So let's just go back here, and we have pretty sided, so let's just change the radius. Right now we have a value of 0.59, and let's just try a value of maybe 0.3 for the radius, and we should see this edge getting smaller and smaller. This feels almost good. I think it's too saturated, so let's just reduce the saturation, and now we get a more like a brighter color bleed. I think the color itself still needs some work. We can try to increase the saturation slightly and maybe go a bit towards the yellowish, and let's see what that looks like. All right, this is now almost yellow, so let's check one more time. This is definitely more saturated and definitely more orange. So let's boost saturation, see if that helps already. If it's updating. Did it not update yet? Let's just change those parameters. And I think we are slowly getting somewhere where we need it to be. Bit more reddish. Yeah, that's somewhere we want to go. All right, so let's just reduce the radius even slightly more. Let's just maybe try 1.75, and now we should have a very small radius, and let's just render for full image. So now we have our render, and it looks like that. If I hit home for 101 resolution, you can see now with this backlit image we can actually evaluate quite a few things. We can see how the light bleeds through the geometry, through the plastic, through the legs. It's pretty nice. I also have rendered a few more scenarios. So if I hit the up key on my keyboard, this is now on high render settings. You can see on the top I switched them from medium to high, and that's the same asset in the sun environment, and you can see everything behaves very, very smoothly and it does not bleed too much. So this is just a good way to test your look dev. Always render in different scenes and just see how it behaves. And I have one more, which is the garage, which is more or less globally lit, very flat, all the lights like 360 degrees, and that's a way to evaluate like kind of a constant diffuse light environment. And you can see in this environment the bump feels a bit too strong, so we might need to adjust it on the head, but I think for this lecture this is just fine. And one last thing I want to show you is how to get actually an image, like a texture, onto a part of a geometry. And let's see, I also rendered the studio in high, so it's actually cooking right now, just to compare the render settings from let's see if it's those two, from medium to high settings, and you can see quite a lot of the noise gets actually cleaned out. You can see it in the hands here, it gets a lot cleaner. And this would be the final or the high render settings for the studio. So let's just head back over and change the settings first to medium, and let's just render or just have our viewer at the VS Studio. So the next step, as I just said, was to add an image to all of this. So for this, because we are doing just simple color overrides, if we plug in now a texture into our network material, those assignments will get removed. So in a normal case or normal scenario, you would actually have only textures driving the look. You would not really have constant colors like I have right now. So matter of fact, let's just copy this network, paste that, and just rename this to maybe, let's just call this maybe Lego ADV for advanced, or what have you, some other name, and hook that up to our material merge. And like that, hit a dot at the bottom here and hook that up, and now that is connected as well. So if I jump into that network and I just want to keep the noise and all of that, all I want to do now is just create a file node by hitting our S shortcut, type in image actually, and just navigate to that location on disk, and let's just choose that under browse, go to our directory, go to source and choose the correct image. And let's just choose the 101. I think this one should be it. Hit accept. And this is our, let's just call this face image or what have you, something like that. And just connect that out into our subsurface color, which we have right there. So this is now connected. And right now it's not assigned because our material assign stack does not incorporate that. So let's just duplicate the Lego one and just maybe prefix this with ADV, or just as we did the shader ADV, and choose the head object, which lives under head. Drag that into our path cell statement and change our shader to be that Lego ADV matte for that material. So now in our scene graph, you can see that the Lego ADV is hooked up. And let's just see what we get if we render now the head only. Let's just for quick iteration, just to see if it actually is assigned and everything is working as expected. And now you can see the texture, as simple as it is just connected. If the UVs are right and your colors are correct, it will just work out of the box. So if you have different textures for different parts, you can just do it like that. If you have textures for everything, you can go get away with just having one texture, which is maybe a UDIM tile texture, or you just have different tiles and your model is in different tiles, so it will work also automatically like that. And the next step would be to maybe we can add some occlusion or just some breakup to everything. If we want to do that, we can head back into our network material like that, and we can just create, let's go into the basic one, and let's just create something which adds maybe a little bit of dust to everything, and then this should be it for this lecture. So hitting S and just typing in occlusion. Oh, let's actually use curvature. Do something else. Let's just use curvature and just break up, let's just break up the colors and break up the edges or something like that. So in the Lego, let's just, let's actually change the roughness. So in my specular roughness, currently it's on 1.5. All I want to do now is change it based on the edges. So it's very straightforward. What we can do here is just, first of all, maybe create a ramp, hitting S, a range, like that. So we have flexibility to control the curvature. This goes into the range input. And this would now, the out color red would drive the specular roughness for this. Let's just connect that up. This is typical Lookdev work, so nothing too fancy going on here. Let's just render maybe the arm area like that, and do a live render like that. And then all we have to do is visualize the curvature and adjust the range for this. So let's see how that will work. Normally the curvature has pretty good values, so let's just need to dial it in a bit further. We might actually create a constant shader just to visualize it rather quickly. So hitting S and typing in flat shader like that, and we can hook this up with the out goes into the flat like so. I'm not sure this doesn't update right now. So now if I just change the range, maybe just clamp it, or actually let's just try visualizing it by connecting the flat shader here and see if that actually does update it. So now let's just tweak the curvature values a bit, maybe add a few more samples, maybe 10 for this, and reduce the radius by a bit just to get a smaller range, maybe half that. And we can play around with the spread and the multiply and the bias a bit later just to see if we get a nicer match on that curvature node. And the next step would be then to change the range a bit. So we just want to clamp it a bit, maybe 0.1 and the blacks. And now you can see it's clamping it a bit more. We can go back to the curvature and multiply it a bit, maybe a value of 3 to get wider whites. Boost everything a bit. Let's just see what that looks like now. So this might just work. So right now we are controlling the roughness directly. So whatever is white like that will change the roughness value. So what we want to do, we actually want to enable smooth step so we don't get values higher than 1 and no values lower than 0. So what we can do now is just specify our minimum and maximum roughness value. So I want to have a minimum of maybe 0.05 and a maximum maybe 0.25, and this should be my range of my roughness. So whatever is black is a value of 0.05 and whatever is white should not exceed 0.25. And what we want to do now is just maybe expose this value as our specular roughness. So in the edit parameter, let's just do that again to maybe specular underscore roughness, like that. And group would be specular. So this is now exposed, and let's just see how we handle it in this case. So right now we are exposing it as well, but we can just get rid of that actually. So we are not exposing this value, but we are exposing the range max. So let's just hook up this shader into the surface shader, and let's just see if we get everything as expected. If I render now the full image again, you can now see that the render returns, and we should be able to see that we have a bit rougher edges, just because it's based on the curvature. And if we look into the specular direct, we can see that these edges are a lot softer than, for instance, the arms, which are flat lit. And now we can see that this would be our little Lego figurine, where we did some quick and easy look dev on it, and we can see it actually works in all of these environments. Fairly cool. So this should be a very cool lecture, how to set up some look dev, how to do overrides within this asset work area to maybe change the colors for different parts of the geometry. And the final step would be to actually bake all of this out into a KLF, so we can actually test this in a shot environment. So edit the look file, bake, and just let's have a look if everything is set up properly. So we are baking the location LG01 because this is where our main asset comes in. We are writing it to our scene location plus scenes and then look dev. So let's just hit write look file and just overwrite what we did here. And now this file is being baked out to disk. And on the other side, which is not yet fully developed or the templated, we have our little small lighting environment. So in the Importomatic, I can actually choose a path, which is, let's just actually delete this and just create a fresh Importomatic so you can follow all of the steps. Hook this one up, edit this guy, hit the plus, add a lambake, and go back to our source folder and choose a Lego shot. Accept that. Make sure the path is just going into Geo. And if I double click to view from here, you can see now we have quite a few little Lego figurines. And you can see now the instances are working as expected. We see 1 till 10 little characters. And all we gotta do now is do the look file assign. And instead of doing it on the LG01, which would assign the look file to only the first instance, we want to assign it to LGO asterisk. And if I display these results, we can see that every LGO instance gets added to this assignment. And obviously this look file, the asset in the look file assign points to our baked out look file, which we just created. And right after that, we have a look file resolve. If I view from here, you can automatically see that all of our instances, they got this black plastic shader, which is our default plastic. And if I maybe go to number 4 and click on the arm, left arm, and I check my attributes and enable implicit resolvers, we can see that we get this blue shader or blue override on this guy. And this is exactly what we want to see. So if I go back to the node graph, and let's just click on my render settings, and I go to my render camera, which is right now square, nothing too crazy. I can just change the resolution fairly quick to H to maybe half HD. We want to do a width adjustment or height adjustment, frame this a bit, and let's just render and see what we get here. And as easy as that, you can just assign shaders to all of these instances and everything will just work out of the box. We could do now variations based on instances and all that. But I think this is showing you a concept which should make sense for you. And I'm pretty sure you can see the flexibility you have once you understand that look dev and lighting are two separate identities. You can fairly easily work in one environment, bake out the KLF, go to your lighting scene, update the look file, and you be done with that. No need to do some shot overrides or make a messy workflow out of this. So this is very straightforward and clean. So I hope you enjoyed this lecture, and I hope this helped you just to understand how the principles of Lookdev work in a bigger production company, or just in a more structured and organized pipeline. So thank you guys for watching this lecture, and I will see you in the next one.